Today I'm going to talk to you about differentiating by first principles. And in order to do that, I'm going to just go over here on the grid and I'm going to draw a function y equals some f of x. And let's just give this line two coordinates on the line. Let's call this p and this one q. Now what I'm going to do is I'm going to work out the gradient. I'm going to join the 2 points up and I'm going to work out the gradient between these points, the secant. What we do is we have some x coordinate at q, and of course if y equals f of x, then this y value is just f of x. And let's have a look at p. Well, p has come along some distance. Let's assume that distance is h. So this x coordinate's x plus h, which means the y coordinate for this is now f of x plus h. And essentially, if we're going to work out the gradient between those 2 points, I'm going to take its rise and divide it by its run. So if I do that, I get f of x plus h minus f of x divided by x plus h minus x. Now, if we simplify that, we end up getting f of x plus h on the top minus f of x, but divided by h. Then what we do is we consider, well, what's going to happen as the gap between p and q closes in. So what we do is we consider what happens as p gets closer and closer and closer to q. The value of h gets tiny, very, very small. It decreases so much so that it's so small it's almost insignificant. PQ, the secant, has become the tangent of the curve at point Q. So this then takes us to limits. What we're going to do is we're going to now study the gradient. This is the notation that we use for the gradient rather than m. And then what we do is we look at that limit of when h tends towards 0. Now this is effectively called differentiating by first principles. I'm going to go into a couple of examples. I'll just pause and clear the screen. Okay, so I'm going to find the derivative of the function f of x equals x squared minus 2x using first principles. So to begin with, we write down the rule for first principles. So it says the gradient is the limit as h tends to 0 of f of x plus h minus f of x all divided by h. Over on the left, I'm just going to write down what f of x is, and then I'm also going to write what f of x plus h is. So you remember through function notation, wherever I see x, I need to replace x plus h. So I get x, so I'm rewriting this, but instead of x, it's x plus h all squared minus 2x plus h. That's my f of x plus h, which goes on the top. That's f of x, so I'll eventually subtract the two. It makes it easier on the left-hand side if I just simplify the f of x plus h, because I've obviously got a quadratic here. So if I just expand this bracket here using FOIL, or using a perfect square as it is, I end up getting x squared plus 2xh plus h squared. And then over here, if I expand this bracket, I get minus 2x minus 2h. And looking at that, there aren't any like terms at this point, so now I can now substitute it all back into this formula. So I'm now going to use my f of x plus h and place it in here, subtract my f of x. So let's write that down. So I'll just carry on over here. I need a little bit more room. So I'll write really small to see if I can fit it in. So I've got x squared plus 2xh plus h squared minus 2x minus 2h. And obviously I'm taking away f of x now, which is this, and when I subtract that, all the signs change, so it's minus x squared plus 2x. And that's all divided by h. Now let's simplify the numerator. So we've got an x squared and a minus x squared, and we've got a minus 2x and a plus 2x. So let's see what we're left with. We're left with 2xh plus h squared minus 2h, all divided by h. Now you'll notice the numerator all have a common factor of h. So I'm going to pull that one out. And if I pull that out, oops, apologies, put the h there, I get 2x plus h minus 2, all divided by h. Now one thing about the limit is as it tends to 0, we can't divide by h at the moment, but it's okay because When we cancel the h's, that makes 1, so we're just left with the numerator. So when we evaluate the limit as h tends towards 0 of 2x plus h minus 2, if we substitute 0 in for h, we're left with the derivative of this function here, which is just 2x minus 2. So continuing that, f dash of x, ideally I'd write it underneath, I've run out of room, f dash of x equals 2x minus 2. And that's pretty much how you would go through the process of differentiation by first principles.